All right, so in this example now, even though we're still dealing with three variables, but these equations were purposely written with some missing terms. And you're going to see that it's super simple, or at least very similar, that's what I should have said. It's very similar to what we did before. And so you'll see that right now. All right, so the kind of system that we want to follow is you take two equations, you eliminate a variable, take another two equations, eliminate that same variable. So now you have only two variables that you can do that system. So we want to do that same kind of mindset. And there's multiple ways that you can approach this. So I'm going to take one way, and then maybe at the end I'll just say, oh, okay, like you could have done it this other way or something like that. So I'm looking at this right now and I see, okay, this has an x and a y, and this has yz, and this has an x and a z. So it would make sense to me, at least, to get rid of the z variable. Okay, meaning if I look at this equation, see how there's no z? So I'm like, oh, so then why don't I take these two equations right here, take these two, manipulate them so that the z is gone, and then I'll have left x and y. Okay, so this is what I mean. If I wanted to get rid of my z, I would need to multiply this guy. Let's see if I want this to be maybe 20. Multiply that by 4. And if I want that to be 20, I multiply that by 5. So if I do that, this is what I get. I'll get 8y plus 20z is equal to 4. Same thing right here. I'll get 15x minus 20z is equal to 40. So check this out. Notice what happens here. See, the z's cancel, and I get 8y and 15x. Well, you can't combine those, so you just get that. 15x plus 8y equals 44. Bam! So look, I have one equation that has x and a y, and I have a second equation now that equals x and a y. And that's what my goal was. I knew that when I combine these, I knew that when I combine y and x, it's just going to give me x and y, right? And that I could just get rid of those guys right there. So I'm going to go ahead and put these two guys together, and I'm going to go ahead and solve my system equation. So I have x minus y equals 6, and 15x plus 8y equals 44. So let's see there. I think what would just make sense if I just multiply this top one by 8. That would eliminate the y, so 8 times x, 8x, 8 times negative y, and then 8 times 6 is 50, or 40, 48, right? I guess kind of forget that there. All right, and then we combine those together. So I get 23x. What the? Those are gone. And I'm going to get 92, right? Divide by 23, and I get 4. Sweet. So again, x, y, and z. So I know my x is 4. So which is nice. If I know my x, then I can find my y, right? So I'm going to do that. 4 minus y equals 6. Subtract 4. So that means if I divide both sides by -1, I get y equals -2. Then if I want to find z, I can just plug it into the second or the first equation. It doesn't matter which one I'm going to do there. Maybe I'll just do the second one. So if I do the second one, 2 times the y value was -2, plus 5z, I don't know the z one. So this right here is, this is -4 plus 1 is 5. Divide by 5, z is 1. So, oops, I guess I should have switched that right there. Okay, so my y was -2, right? Yes, and my z is 1. Good, so this is what we should have got right there.